Hello, check. Alright people, welcome to Catalysis by Vedantu. My name is Pahul. If I'm audible and visible, please write here in the chat box. You know the drill. I think we are live, yes. So my dear friends, today we will continue the chapter of thermodynamics, yes. And in the previous few classes, what we have done is we have learned a lot about the basics of thermodynamics, what is heat, what is work, etc. And in the previous class, we had tried to understand how to derive work done for an isothermal process, and we had seen some other properties as well of the first law of thermodynamics. Yeah, so today what we'll do is we'll solve a bunch of questions. Okay, so while solving these questions, we learn a lot of new ideas. We'll learn how to apply whatever we've learned in thermodynamics till now. Okay, and then we will graduate to some more processes. We have seen the isothermal process. We look at an adiabatic process, an isochoric process, an isobaric process, and we'll try to understand how to figure out the work done in those processes, how to figure out the heat in those processes, etc. etc. Okay? So, ready for the very first question for today's class? Yes, if you're ready, write ready in the chat box. Let's look at this question. Determine the sign of delta U, W and Q in the following processes. So you just have to determine the sign. And since we are in a chemistry class, I hope you remember that for work done, compression is positive work, expansion is negative work in chemistry. Yes, so I hope you remember that. तो चलो बताओ क्या होगा यहाँ पे. We have to figure out the signs of internal energy change, work and heat in each of these processes. So first of all, let's look at process number 1. What have been given to us are PV graphs. Okay, PV curves दे रखे हैं यहाँ पे. So what's happening in this curve, my dear friends? ये जो curve अपने पास बनाया, I'll make it once again over here. In this graph, when I go from 1 to 2, all right, when I go from 1 to 2, what is happening is my pressure is increasing, my volume is also increasing. Yes. Do you understand? And yeah. Cool. Do you understand? The pressure is increasing, the volume is increasing. Since the volume is increasing, do you realize that this is an expansion? Since the volume is increasing, this is an expansion. So this implies that work, okay, this implies that work done will be negative. Understand? Expansion in chemistry means that you have negative work done. Alright, so since this is an expansion, work done sign is negative. Okay, makes sense? Cool. Now people, the next thing that we need to figure out is delta U. Now delta U ka kya kare? How do we figure out the change in internal energy? I hope you remember in the previous class I had given you a hint in one of the questions that the internal energy is proportional to temperature. Remember, internal energy of a system is proportional to temperature, right? So if it is proportional to temperature, let us try to figure out what is the change in temperature over here. My dear friends, do you understand that PV is increasing? The quantity P into V is increasing over here. So can I say this implies my temperature is increasing? Since I can say temperature is increasing, do you realize I can also say that internal energy is also increasing? Yeah, delta U will be greater than 0. Do you understand this idea? Since PV is increasing, temperature is increasing, it implies that delta U is greater than 0. Yeah? तो ये काफी सिंपल हो गया. So अपने पास क्या चीजें आ गई? W is negative. This is chemistry convention, not physics convention. Okay? तो ये हो गया. Work done is negative, temperature is increasing, so delta U is greater than 0. So how do we figure out Q? Q is very simple. Delta U is equal to Q plus W. Delta U is a positive value, question mark, plus negative value. So obviously, since delta U overall is a positive value, Q has to be positive. Do you understand? This guy has to be positive, otherwise delta U will not be positive. Yeah. So finally, for the first process, we can say delta U is greater than 0, work is less than 0, and Q is greater than 0. Fine. Simple ideas. Step by step, we deciphered everything that's going on. So in the second part of the question, let's gather a little bit more speed. Okay, let's try to do it a little faster. So what's happening over here is PV graph is given, but volume is not changing. Can you see that the volume is a constant value? Straight line, so volume is a constant value. Since delta V is equal to 0, can I say that work done is equal to 0? Because what's the formula of work done? Work done is equal to minus P dV integral. Integral of dV is 0 because there is no change in volume. Delta V is 0. Yeah. V final minus V initial is 0. So work done over here is 0. That is amazing. Yeah. Now since volume is not changing, pressure is decreasing. Can you see the downward arrow on this process? नीचे को arrow बना है. Since pressure is decreasing, can I say temperature is also decreasing? Can I say temperature is also decreasing? Yes. So pressure is decreasing, temperature is also decreasing. So my dear friends, because temperature is decreasing, I can say delta U is less than 0. Internal energy change will also be negative. Yeah. Internal energy change will also be negative. Fine. So P decreases, temperature decreases, implies delta U also decreases. So since work is 0, delta U is less than 0, this implies Q is also less than 0. Delta is equal to Q plus W, W is 0, so delta U, if it is negative, Q is also negative. So in the second part, work done is 0, internal energy change and heat is negative. Heat is taken out of the system. It's an exothermic process. Yeah, right? So this is very simple for the second part. Let's figure out the third part. Now in the third part, look very carefully. The graph that is given is a pressure versus temperature graph. Can you see it's a PT graph? It's not a PV graph anymore. It is a PT graph now. Okay. So what do we do with a PT graph? Pressure temperature graph का क्या करें अब अपन? Yeah. So people over here, very simple. You can see that the arrow is upwards. Yeah. The arrow is upwards. Temperature is not changing. Temperature, straight line, temperature is not changing. So I can write over here delta T is equal to 0. Since temperature is not changing, I can simply say that change in internal energy is also 0. Yeah. Now since change in internal energy is 0, delta P, okay, or simply I will say pressure is increasing. You can see the upward arrow. This implies volume is decreasing. If volume is decreasing, this implies compression. And we know for chemistry, compression means we are doing work on the system. So over here, this implies work done is greater than 0. If work done is greater than 0, internal energy is 0, I can simply say Q is less than 0. Why can I say this? Because delta U is equal to Q plus W. So if work done is positive, if W is positive, Q has to be negative to make delta U is equal to 0. So always remember from now on, this question helps us learn one very new important thing, that internal energy of a system is directly proportional to temperature and nothing else. Do you remember we've done something like this in the kinetic theory of gases? For internal energy of a kinetic ideal gas system, what do we say? We say that U is equal to 3 by 2 nRT. This is what the addition of kinetic energies in an ideal gas. An ideal gas doesn't have any potential energy. They don't have any forces of interaction. They only have kinetic energy. So from ideal gas theory, from kinetic theory of gases, we know that internal energy depends only and only on temperature. And we solved a very beautiful question in the chapter of gaseous state related to this as well. Yeah, okay. So this is the idea for this question. Very beautiful. Right? So chalo ye ho gaya. Now my dear friends, what we should do next is another question. But before we do that question, I am very excited to announce, as it says on the screen, that we have launched a brand new channel, Vedantu NCRT channel for 11th and 12th class. So what we'll do over there is all your NCRT was, how to read NCRT, what to read in NCRT, how to solve questions in NCRT, all the solutions, examples, etc. will be there on this channel. So in case you want to know more about this channel, the links for that channel are in the description box down below. Please check it out. Next question is, in which of the following processes work done by the system is maximum and minimum? My dear friends, you have to read the question very carefully. Let's read it once again. In which of the following processes work done by the system, read this, work done by the system Okay, we are talking about work done by the system, and in which processes work done by the system, maximum and minimum. I'll remind you once again that work is done by the system. Okay, work is done by the system to expand. Do you remember this? Expansion means negative work done. It means that I am not doing work, the system is doing work, the system is losing energy. So over here you think about the magnitude of work. You think expansion, more expansion implies more work done. Something like that. ठीक है? तो ये एक idea आ गया, work done. Work is done by the system to expand. This is one idea. Second idea that I'll give you, that work done, the magnitude is equal to integral P delta V. Magnitude is integral P delta V. What is that equal to? Work done is equal to area under the PV graph. Area under the PV graph, if P is on the y-axis, V is on the x-axis, then the area is the work done. So you have to use these two ideas in order to figure out the answer to this question. As simple as that. So my dear friends, what's happening is that all these processes, A, B and C, all of them are expansion. So in all of these cases, work is being done by the system. Can you see? Volume is increasing in all cases, volume increases in that direction. Yeah, so volume is increasing in all of these processes. All of these processes are processes of expansion. Yeah, now since all of them are expansion, all you need to figure out is किसमें area ज़्यादा है? Yeah, so in which case is area more? Obviously I can see that area of A is greater than area of B is greater than area of C. You want me to highlight? Okay, I'll highlight it as well. What is the area under A? This entire thing is the area under A. Can you see? My board starts shaking. But yeah, that entire thing is the area under graph A. This part is area under B. Yeah, and the remaining part over here, this is area under C. Okay? So area under the PV curve is your work done. Area of A is greater than area of B is greater than area of C. So my dear friends, work done by the gas to expand is the most. Okay, my hold on a second. The camera angle has been disturbed a little because my cats keep playing in this room. Hold on. Hunch. Yeah, my kittens play around all the time. Anyway, so A में work आएगा maximum. Yeah, work done by the gas in A is maximum, and in C, work done by the gas is minimum. Yes? ठीक है? Got it? Alright. So this is the idea. That's how we need to go about this particular question. ठीक है? As simple as that. So honey, they are playing around. If one of them comes close, I'll pick them up. They don't like getting picked up. They're very small. Can you see? This is Leona. She doesn't want to be picked up. Chalo ji. So I hope this is a question that you understand. Now, next question. Before I go there, let me show you another piece of great news. So the news is that we at Vedantu run full courses on Vedantu's patented platform. See, you all know that to get into your dream college, you need a lot of guidance. Yeah, everyone needs guidance. Yeah, you need to know what to do, when to do, exactly how to do it, rank, etc., etc. You should know your rank compared to other people. So for that, a proper course in a proper coaching institute is absolutely necessary, and everything these days is online. Vedantu is a very good option for you. You will get live classes with master teachers on Vedantu's patented platform. You will have lots of assignments given to you, study materials, tests, mock tests every weekend so that you can rank yourselves among the other people of the class. So everything that you need is there in this course from A to Z. So in case you want to join, the links, this link is in the description box down below, and this is the coupon code that you can use to get yourself a very nice discount. Do check it out, okay? Chalo. Next question is this one. An ideal gas undergoes a cyclic process as shown on the PV graph. Calculate the work done in each step and in the whole process. Very nice question. So what's happening over here? What's happening over here? The graph is going from 1 to 2 to 3 to 4. Okay, these arrows are a little misdrawn. I'll draw those arrows once again for you. So you are going from 1 to 2 to 3 to 4 back to 1. Okay, so you start from 1, you go to 2, you go from 2 to 3, 3 to 4 and 4 back to 1. Okay, so let us try to calculate the work done in each of these processes step by step. Let us look at process 1 going to 2. So my dear friends, in process 1 going to 2, do you realize that pressure is a constant value and that is 300 newtons per meter square? Yeah, pressure is equal to 300 newtons per meter square. That is your SI unit, Pascal. है ना? And volume is also given in the SI unit, which is meters cubed. Right? ठीक है जी, तो ये हो गया आपके पास. Now people, since pressure is constant, what is the formula for work done? Is equal to minus integral of P delta V, or P dV. Yeah, pressure can come outside, minus P integral dV. Integral of dV is what? Minus P delta V. Okay? So whenever pressure is a constant value, whenever you have constant external pressure, don't think about these formula too much. It is just minus P delta V. Okay? तो यहाँ पे कैसे निकालेंगे work done? Work done will be 300 with a minus sign into V final minus V initial. That is what delta V is. Okay. So what is V final minus V initial? Minus 300 into final volume is 60 minus initial volume, that is 20. So कितना आ गया work done? Work done is equal to minus 12,000 joules. Yes. तो क्या मैं लिख सकता हूँ? This is 12 kilojoules with a minus sign. Is that correct? Ow. ठीक है? Yeah, 300 into 40. 3 into 4 is 12. 100 into 10 is 1000. 12,000. So minus 12 kilojoules. Is that correct? Is that fine? People, please be a little more active in the chat box. In the sense that you answer my questions instead of just chatting with each other. ठीक है? People, why are you so dead today? Random chatting going on in the chat box. क्या चल रहा है? People, if you're alive, write alive, please. I was expecting multiple people to give the answer, but I think only one person gave the answer, and that was 1200, which is wrong. Okay? ठीक है? Okay, awesome. Now I can see a lot of people there. Thank you. Thank you so much. Great. So this is for process 1 to 2. तो यहाँ पे साइड पे लिख लेते हैं इसको. Yeah. For process 1 to 2, I'll just write it over here. The work done is, since it's an expansion, we expected it to be a negative sign here. So this is minus 12 kilojoules. Great. Now, what about process 2 to 3? My dear friends, do you realize process 2 to 3? ये दिखेगा नहीं शायद आपको पेन. Process 2 to 3, this process, the volume is not changing. The volume is not changing, and we have just seen, we have just seen that for an isochoric process, volume is not changing means isochoric process. So for an isochoric process, since delta V is equal to 0, I can simply write work done is equal to 0. Similarly, I can say for this one as well, 4 is to 1. For process 4 going to 1, for process 4 going to 1, again work done is equal to 0 because the volume is not changing over here. So the only thing remaining for us to calculate is what about process number 3 to 4. What about process number 3 to 4? क्या करें अब process 3 to 4 में क्या कर सकते हैं? What can we do? So for process 3 to 4, same thing that we have to do. Constant pressure into change in volume. V final is 20. Initial volume is 60. This comes out to be 4000 joules. Yes, 100 into 40. तो इसको मैं सिंपली लिख सकता हूं 4 किलो जूल्स. सो माय डियर फ्रेंड्स, व्हाट इज द टोटल वर्क डन? Total work done is just the addition of all of these. Yeah, total work done is just the addition of all of these. So total work done is equal to minus 12 plus 4, that is minus 8 kilojoules. Okay, ठीक है. So total work done will be minus 8 kilojoules. For ABC zone, work done is positive over here, my friend, not negative. Okay, because this is a compression process. In compression, our work done is always positive. That's the convention we follow in chemistry. Remember that, please. Okay, ठीक है. Arvind is saying, sir, find area under curve to find work done. वही तो कर रहे हैं दोस्त. That is exactly what we are doing. This is area under the curve. वही तो किया. Yeah, you are calculating the area under the curve by doing P delta V. Absolutely. Okay, चलो जी. So overall आ जाएगा minus 8 kilojoules. Now this is the total work done. My dear friends, my next question to you. Okay, let's add up to this question and learn something new. इस पे कुछ add करते हैं और कुछ सीखते हैं. Okay. Total work done in the cyclic process. Why am I saying cyclic process? Because it comes back to its original state. One complete cycle. All right. Total work done in the cyclic process is minus 8 kilojoules. Can you tell me what is the total heat given / taken in the entire process? Can you tell me what's the value of Q for the entire cyclic process? बताओ, क्या सोचते हो आप? My dear friends, for this, let me give you a hint. The hint over here is something that we had discussed very briefly in the very first class. The hint over here is that your internal energy U is a state function. Okay? Internal energy is a state function. All right. So internal energy is a state function. फिर what's the significance of it? एक सेकेंड दोस्तों. Do you realize that we are starting from the same state that is the final state? Do you realize over here that initial state is equal to final state? This is a fact that you can remember. Internal energy is a state function. I'll tell you how to imagine about it, how to make sense of it. ठीक है? So since internal energy is a state function, this means that since you are coming back to the same state, delta U is equal to 0, isn't it? Since internal energy is a state function, delta U is equal to 0. So my dear friends, since delta U is equal to 0, I can simply say that the heat given in the process is negative of work done. Total work done is minus 8, so total heat given will be plus 8. This comes out to be plus 8 kilojoules. As simple as that. So the thing that you have to remember over here is that internal energy is a state function. ये कैमरा एंगल मस्त एकदम टेढ़ा मेढ़ा हो गया है. Just a second, okay. Let me try to. Hold on, people. थोड़ा सा जोर लगेगा इसको सीधा करने में. हाँ, अब सीधा हुआ ये. You can note it down until then, the question or the fact. And if you don't want to note it down, then yeah. Fine. I think I'll have to lock these two in a room from tomorrow onwards during the class. Anyway, so this is done. Now the question is, how and why is energy, internal energy, a state function? My dear friends, think about, okay, think about the potential energy. Yeah, let's say this is the bottle. Okay, this is a bottle. Does it matter what is the absolute potential energy of this bottle right now? Absolute potential energy. I'm going into physics right now. Okay? So what's happening is, let's say this is the base. This is the base where the bottle is initially. Now, if I raise the bottle from here to here, if I raise the bottle from here to here, can you calculate the change in potential energy? If this height is h, can you calculate the change in potential energy? आ जाएगा ना, you know, mgh, I think that's what it was. I don't really remember the physics formulae, है ना? तो ठीक है, यहाँ पे था, initially it was here, then I put it here, so this is the height, so you can calculate the difference in potential energy. My dear friends, does it matter what is the exact potential energy here? Does it matter what's the exact potential energy here? No. I only worry about what is the difference in potential energy. Yeah? Do you see where I'm going? No matter how far it is from the ground, I can, without even considering its height from the ground, calculate the potential energy difference from here to here. And if I start from here, if I move around the entire world and then come back to this place, is there any change in potential energy? No. It still will fall to the ground with the same amount of force. Yes. So, similar to potential energy, internal energy is also a state function. What is internal energy? Internal energy is the addition of kinetic and potential energies inside a system. So the properties are the same. Yes. Potential energy, its absolute value doesn't matter. होगी कोई 2506 kilojoule. I don't care. Yeah. All I care is how much is the difference in potential energy from this point to this point. Yeah, so that is how you can think about potential energy, kinetic energy, and hence total internal energy to be a state function. Okay? So now you understand state function, and similarly we can realize over here that heat and work are path functions. Yeah, do you realize that heat and work are path functions? They depend on the path. Even though I brought the initial state back, there was some work done, there was some heat given. Now if I do this process, yeah, instead of doing this process, if I do this process, I still bring it back to the same state. Do you realize in this process the work done and the heat given will be different? Yeah. Do you realize the work done in this process and the heat given in this process will be entirely different? So the heat and work done are path functions. Internal energy is a state function. Always remember that. Fine. So learning with the help of questions is the best way to learn. Now let's move on to this. This is something that I had taught you in the previous class. Yeah. In the class that we had done on Thursday. So Tuesday. Yeah. So on Tuesday, the class that we had derived a formula for work in an isothermal reversible process for an ideal gas. Yes. What was the formula? W is equal to minus nRT ln V final upon V initial. Do you remember this formula? Minus nRT ln V final upon V initial. Do you remember? Verify we kar lete hain. If V final is smaller, V initial is larger, this value is less than 1. Ln of less than 1 becomes negative, 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 positive. Compression is positive work done. So remember this, if you are always confused between V final, V initial or V initial, V final, you know, what divides what, then think about this sign. If V final is lesser, it means compression, work done should be positive. This less than this implies ln of that quantity is less than 0. It is negative. So if the ln is negative, there is already a negative sign. Overall, this becomes a positive quantity. So this is the correct formula. Now I had given you guys a homework to calculate the formula in terms of pressure. How can I do that? Very simple. Use the ideal gas law. This is equal to minus nRT ln of, कैसे लिख सकता हूं मैं? V is equal to nRT by P. So can I write it as nRT by P final upon nRT by P initial? लिख सकता हूं ना, V final upon V initial is as good as nRT by P final upon nRT by P initial. So my dear friends, simplify this. What will you get? You will get ln of P initial upon P final. Yeah, just use the ideal gas equation over there, since this formula was for an ideal gas. So what I can do is I can absorb the minus sign. I can put the minus sign inside ln. Yeah, अगर minus sign मैं ln के अंदर डाल दूं, this becomes raised to the power minus 1. So I can simply write plus sign nRT ln P final upon P initial. You can remember it however you want. जैसे भी याद रखो. You just need to remember one of the ideas. All the other formulas you can derive it directly in the examination as well. Yeah. No need to remember all of it. Derive कर सकते हो कभी भी. So let's see how many of you give me the correct answer. This was your homework question. Let's see the chat box for the previous class quickly, and let's figure out how many people gave the correct answer. Just give me one moment. Bum 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 bum. Yep, I have opened the previous classes page. Here it is. All right, so this is what this is your lecture number 3. Yeah, and lots of comments. Thank you so much for the comments, people, and sorted the comments by newest first. So let's go at the end और देखते हैं किसने सही आंसर दिया. माइनस एनआरटी पी इनिशियल बाय पी फाइनल, एब्सोल्युटली करेक्ट. माइनस एनआरटी लॉन पी इनिशियल बाय पी फाइनल, correct. So Catalysis Army has given the correct answer. Jatti has given the correct answer. Aman, correct. Keert, yes, that is correct. Very nice. Shrija, I'll talk about that towards the end of the class. Please remind me if you are there in the class today. Nilanshi, absolutely correct. Education Elixir, I have taken a lot of crash course type classes on the channel itself. Yeah. Kuldeep, correct. Vedant's fan club, very good job. Psychotonic, interesting name. Yeah, correct. And yes, Guru Vammai Ramaswamy, I hope I'm pronouncing your name correctly. Guru Vammal Ramaswamy. Okay, bro, sorry, I couldn't pronounce your name correctly initially. But yeah, good job. Vardhan, very nice. And Lavanya, that's absolutely correct. Yeah, Jatin, I'll have to find some better music, man. And people, thank you so much for your compliments. Suman, again, correct answer. Gratrium, very good job. Kostav, correct answer. चलो जी, गगन, very good job. ठीक है, काफ़ी लोगों के नाम ले लिए मैंने. I've taken the names of a lot of people. Good job, people. Nice. So now, let us solve some questions using these formulas. अब formula किए हैं तो question तो solve करना बनता है ना. So this is one more question for you today. Yeah, today's class is full of questions only. 1 mole of an ideal gas is expanded isothermally and reversibly from 5 atm to 1 atm at 300 Kelvin. Calculate the work done in the entire process. Simple, nothing complicated about it. We just learned the formula. W is equal to nRT ln of P final upon P initial. Yeah, or you can do minus nRT ln P initial by P final. Yeah, कर सकते हैं. Ln P final upon P initial can be written as 2.303, yeah, into log of P final upon P initial. Yes, so now it's all about filling in the values. Let's do some calculation. In NEET, especially in NEET examinations, such questions are also common. Okay, NEET exam में इस तरह के questions are asked quite often. Simple questions, okay? So number of moles are given as 1. R. Let's calculate the work in joules. So if the work is in joules, what will be the value of R? R will be 8.314 joules per mole Kelvin. Yeah. Temperature is 300 Kelvin. चलो ये बहुत ही simple कर दिया इन्होंने question. 300 Kelvin into 2.303 into log of P final is 1 by 5. Yeah, P final is 1, P initial is 5. Yes, ठीक है. So this can be written as minus log of 5. So this is the calculation that we have to do. Can you do the calculation please? What is log 5? Log 5 की value थोड़ी बहुत याद रखी होगी आप लोगों ने. I don't remember the value. I'll Google it quickly. मेरे सामने Google भाई खुला रहता है. Yeah, so log 5 is approximately 0.7. For all of you who don't know, log 5 is approximately 0.7. तो क्या आ गया यहाँ पे? Minus 8.314 into 300 into 2.3 into 0.7. That's what it is, right? चलो कैसे करें? 3 into 8 is 24, 3 into 3 is 9. So this entire thing, okay, this entire thing, I'm doing approximation now, okay? I'll show you how to do the approximation. I'll see the answer from your comments only. So 3 into 8 is 24, so I'll approximate this guy as 25. Okay, I'm approximating this guy as 25. So 25 into 2 zeros, that is 2500. 2.3 into 0.7. अच्छा, तो अब इसको कैसे approximate करें? 7 into 2 is 14. So I'll approximate this guy. 7 into 2 is 14. I'll approximate this guy as 1.5. Is that a good approximation? I don't know. So 25 into 1.5 will give you your answer. So something like this, 3 by 2. तो यहाँ से इसको कर देते हैं 50. So 50 into 3, that is an approximation that I can look at. ठीक है? So 7.5 75 into 5, 3 7 4 के आसपास आएगा, yeah, somewhere around 4,000. So what my approximation says, 25 into 3, 75, yeah, so 75 into 50. So 75 into 50 is 750 into 10, 7500 by 2. So 7500 by 2 is approximately 3800, yeah. So answer should be approximately 4000 joules. Very bad approximation, but again in the examination, if the options are far apart, you can use this approximation. There will be a minus sign, of course, yeah. So exact कितना बता रहे हो आप? 4014. Okay, a few people are saying the answer is 4014. So I will, okay, if you say so, answer approximately कितना आएगा? Some people are telling me the answer is 4014 joules accurately. Fine, great. You are better at calculation than I am any day. चलो जी, ये हो गया. Now let's move on to the next question. So many questions today. I like these classes when we are solving more questions. चलो देखते हैं. What is the amount of heat absorbed by a system in going through a cyclic process shown in the entire figure? तो हो क्या रहा है यहाँ पे? I'll show you what's going on. Yeah, what's happening is you can start anywhere in this process. You can start anywhere in this process. You go from here, go down, go here, go up. This is a cyclic process. Okay, this is a circle, by the way. I know it looks a little more elongated. It looks like an oval right now, but this is a circle. Okay, the image is not very beautifully made. Let's try to fix the image. चलो, image ठीक करने की कोशिश कर देते हैं. Let's try to make it into a good looking circle. Abhi it looks more like a circle. Yeah, a little more convincing perhaps. So this is your graph that's given. You can start at any point. There is, अरे भाई कहाँ चला गया? Yeah, you can start at any point. Starts from here, goes down, moves in this direction, goes up. This is how the process is happening. ठीक है? This is your cyclic process. ऐसा घूम रहा है process, मस्त. So in this cyclic process, you have to figure out what is the heat. How do we calculate the heat? See, if I can calculate the area under the PV curve, I can calculate the work. So what are the thought processes that should go in your mind? What is the step-by-step thought process? First thing is, delta U will be equal to 0 in a cyclic process. If I start from this point, come back to this point, delta U will be 0. Then work done is basically area under PV graph. So if I have delta U equal to 0, work done I can calculate via area. So I can simply do Q is equal to minus of W. So now the idea is to calculate the area under the curve. Now the thing is, the values over here given are very simple. It is very hard to do a silly mistake over here. But do you realize this is a V versus P graph? This is not a P versus V graph. This is a V versus P graph. Okay, ये PV graph नहीं है, VP graph है. So the area under the curve would be in this direction, isn't it? The area under the curve would be in this direction. So what would be the area under the curve, people? चलो सोच के देखते हैं. Let's break down this process into two halves. Let's break this process down into this half. From here to here, let's call this process A. And then from bottom to top, let's call this process B. What is the area for the process A? For process A, I am going from 30 to 10 volume. Yeah. For process A, I can say that work done is greater than 0. Why? Because this is a compression process. Volume is decreasing. Compression, positive work done. So work done is greater than 0. What will be the magnitude of work done? This entire area. ठीक. This entire area is the work done in process A. PV graph उल्टा है यहाँ पे. Now, my dear friends, the second thing is in step number B, your work done is less than 0. And what is the area for B? This is the area for B. Can you see? This is the area for B. So, my dear friends, total work done, okay, let's say this is X, this is Y with a minus sign because negative hai. Total work done will be how much? X minus Y. This entire area minus this area. So total work done in this process is nothing but the area of the circle. Can you see? Very beautiful question. So all you need to calculate is area under the circle, that is positive work done. We have just figured that out. So opposite of that would be the heat. ठीक है? So work done in this process is equal to, अब circle का area निकाल लो यार. What is the radius of the circle? 10 units. Volume is liter kilopascal. Units are fine. ठीक है? So work done will be pi r square. Approximately. Approximately. बोल सकता हूं मैं? हाँ कि ना? बताओ. Adam, we will start the Take 5 series after the NEET examination, okay? $100 pi, yeah. 3.314 लिखना तो 100 pi लिख दो, चलो कोई बात नहीं. So this is the work done. So what is the amount of heat absorbed by a system in going through a cyclic process shown in the figure? Work done is positive, heat will be negative, minus 100 pi आ जाएगा. क्या बड़ी बात है. Pretty simple. Okay. If you start from this point, then this is negative. This is negative work done. This is positive work done. Total work done once again is 100 pi. So heat is minus 100. कोई बड़ी बात नहीं है यहाँ पे. ठीक है ना? Absolutely simple. Kostav, the thing is, Kostav, please listen to me carefully. Delta U is equal to 0 because it's a cyclic process. W is equal to area under the curve, area under the PV curve. Now over here, do you realize it's a VP curve, not a PV curve? So we have to calculate the area in this direction, not in this direction. We calculated the area. This is positive sign of work. This is negative sign of work. So this entire area minus this entire area is the area of the circle. That is the work. So heat is the opposite of that. Ghatiya. Okay. Good question. Simple question yet a good question. So chalo, ye bhi ho gaya. Now my dear friends, this particular question, ye kya karunga main? This is your homework question. There are a few things that I have to discuss with you a little more apart from these questions, but still. So this is your homework question. You have to answer in the comments. The class is not over yet, by the way. There are a few more things that I want to discuss for you in the class, but just please note this down. Okay, just please take down the question. This is the question that you have to answer in the comment section down below for the Hall of Fame for the upcoming class. Alrighty. Suhani, because delta U is equal to 0. Suhani, delta U is equal to Q plus W. So delta U is 0, W is equal to minus Q. Suhani, we started off the question with that. Yeah. चलो जी, ये लिख लिया होगा आपने. Now let us just try to understand and summarize a few things about different processes. Okay, let's try to summarize and understand a few things about different processes. First process that we will think about is isothermal. Okay, first process that we will think about is isothermal. Isothermal process mein what do we know? We know that delta T is equal to 0. Since change in temperature is 0, we learnt today that change in internal energy is also 0. Since change in temperature is 0, change in internal energy is 0. So I can say that Q plus W is equal to 0. So I can say that Q is equal to minus of W. And we have calculated W is equal to minus nRT ln of V final upon V initial. These are the ideas that you have to remember for an isothermal process. This is applicable for ideal gas and reversible conditions. Okay, what is एक second. Okay, so isothermal mein this is general, this is also general, this is also general. This formula, okay, this particular formula is applicable only for ideal gas under reversible conditions. Okay, this particular formula is applicable only for an ideal gas under reversible conditions. All right, done. So this is something that you have to remember for isothermal processes. Now people, let us try to think about isobaric processes. What are isobaric processes? We have learnt in the kinetic theory of gases, we have learnt in the chapter of gaseous state. Isobaric process is where change in pressure is equal to 0. Delta P is equal to 0, pressure is a constant value. Yeah, so if pressure is a constant value, okay, if pressure is a constant value, what can I say? What can I say? I can simply say that for an ideal gas, or I should say for a reversible system, okay, for a reversible system, I can say that P external is equal to P internal. So for a reversible system, if it is under an isobaric condition where pressure is constant, so if pressure external is constant, you can use the formula directly. If pressure internal is constant, then if it's a reversible process, you understand pressure is a constant value. So if pressure is a constant value, work done is simply equal to minus P integral dV. P is a constant value, so it is out of the integral. And what is integral dV? Integral dV is simply equal to delta V. Delta V is simply equal to V final minus V initial. Okay, so just tabulating a few equations over here. Okay, so W is equal to minus sign P into V final minus V initial. Okay, ये आ जाता idea यहाँ पे. Alright, then we look at the next idea of the isochoric process. This is even more simple. Isochoric process mein the volume of the system is not changing. If the volume of the system doesn't change, then work done is equal to 0. So since work done is equal to 0, can I say delta U is equal to Q? This result is very important for us. Very important result. What is this result? This result is that, yeah, एक second. What is this result? This result says that in case of an isochoric process, the heat changed in that system is equal to the internal energy change. Yeah, it's a very important result. If my volume is constant, then the heat given to the system is equal to delta U. Now, I am saying it is very important result. Why is it important? That will be revealed in the next class. This is something that you have to remember. Just remember it for now. Okay. Thermodynamics is like a huge chapter. You will be able to appreciate all of its beauty once the chapter is over. For now, there are some puzzles and hints that we'll keep on dropping in the initial few classes. This is one of those. Please remember this idea that delta U is equal to Q in case of an isochoric process. All right, fine. And then, my dear friends, there is one more type of process which is new for us. That is what we will discuss about a little, and then we'll end today's class. The final process that we have is known as the adiabatic process. What is the definition of the adiabatic process? Adiabatic is a word which means Q is equal to 0. Adiabatic means that there is no heat exchange being done with the system. Surroundings doesn't give it heat, surroundings doesn't take heat from it. Adiabatic process mein Q is equal to 0. So my dear friends, this implies that delta U is simply is equal to W, yes? Delta U is simply equal to W. Now, in this process, how do we use this relation? We need a formula, right? Like for instance, in the isothermal process, we have all formulas. If we know the initial pressure, final pressure, we can calculate the work done. Yeah. In isochoric process, work done is 0. Great. In isobaric process, work done is very simple. P into V final minus V initial. Okay. So the thing is, where are the formulas for these? What is work equal to in terms of pressure, volume? What is delta U is equal to in terms of pressure, volume? And my dear friends, those ideas will start unfolding once we start learning about different types of heat capacities. Okay. So in the upcoming class, what are we going to do? In the upcoming class, we will learn a little bit about enthalpy. Okay, we'll understand the definition of enthalpy, we'll understand the mathematical idea behind enthalpy, and we'll also learn about molar heat capacities. Molar heat capacities are denoted as CV and CP. And in this entire process, we might also discuss the idea of degrees of freedom. So the next class, which will be in the upcoming week, we will discuss all of these ideas. So on 5th of September, Saturday, since it's Teachers' Day, we most likely will not have a class on at 7 p.m. So please stay subscribed on the community channel. We'll keep on updating you with the schedule. So the next class most likely is going to happen on Tuesday at 7 p.m. मैं डेट भी बता देता हूँ एक बारी. Tuesday 7 p.m. is 8th of September. ठीक है, तो 8th of September को next class होगा थर्मो का, and in that class we'll discuss about heat capacities, enthalpy, CP, CV, degrees of freedom, etc. ठीक है दोस्तों. So today we have solved a bunch of questions, understood the idea that heat and work are path functions, internal energy is a state function, and we've also seen how to apply all of the knowledge that we've learned in different questions. We've learned that work done is area under the PV curve, and you have to be a little careful whether the curve given is a PV curve or a VP curve. Yeah. So technically speaking, today's class is done. Today's class is over. Once again, reminding you that at Vedantu, we are running full courses as well. So in case you want a proper preparation from a reputed online coaching, this is something that you should join. Full long-term classes, live with master teachers. You will get assignments, study materials, regular tests. You'll be ranked amongst the people in the batch. It's a proper coaching environment, but online. Great guidance. So you can check out the link in the description box. This is the coupon code that you can use in order to save yourself some dollar bills, yo. Cool? So chalo ji. I will chat with you guys for 2-3 minutes and then we will end the class. Yeah. Cost of thanks, man. Hema, happy dinner. Balaji, I am not yet aware of that news, so I will check it out. Okay. मैं देख के बताऊंगा दोस्त. अभी मुझे news का actually पता नहीं है. Rujula, they've gone into the room. I think now they are tired and they're sleeping. That's all they do. They play, they sleep. They play, they sleep. कभी भी खेलने चालू हो जाते हैं, कभी भी सो जाते हैं. Yeah, so they're inside right now. Let them be. They're very young. I got them just a week back, so they are still getting used to, being around, and they're so young. They have a lot of energy. Eventually, they will mellow down, I think. But yeah, thank you so much for your compliments, people. Ajay, I don't think that will happen, man. NEET already happens in May, so I don't think NEET should be postponed in 2021. Yeah, NEET May में होगा तो वो तो postpone होने की कोई probability से नहीं है. January JEE is something that is subject to postponement most likely. Yeah, ठीक है. Okay, some people are asking how to cover backlog. So I'll tell you, as I've said in some earlier casual sessions of mine, that when I was preparing for JEE, for the first 6-7 months of 11th class, I did not really pay a lot of attention, and that's absolutely true. I did not start paying attention to academics until this chapter. So thermodynamics was one of the very first chapters that I took seriously. Okay, so you can imagine how many chapters I left till that point of time. What I used to do is I started taking advantages of holidays. Saturdays and Sundays, no school, no coaching. Yeah, Sundays there used to be a test, but it was a 3-hour test only. So rest of the day I had for myself. So yeah, take advantage of the holidays. Eventually the festive season is also coming. You guys are not going to school. You guys are sitting at home. तो वो भी बहुत advantage है आप लोगों को. So utilize all that time and take 1 day a week or 2 days a week to recover the syllabus that you've left. Whatever backlog you left, how do you recover it? First thing is read the NCERT. No matter what chapter it is, first thing is read the NCERT. Second, solve all the NCERT questions. That will build up a certain level. Third thing that you have to do is start solving previous year questions of that chapter. Previous year JEE questions or previous year NEET questions, whatever exam you're targeting. So I used to do previous year JEE advanced questions directly. Read it from the NCERT, solve the NCERT questions, then jump to advanced questions. Of course, those were difficult. Yeah, I couldn't do them in one go. So then when I saw difficult questions, I started doing other exercises as well, like JEE main previous year questions. Those are easier, then move to advanced questions. Yeah. So for chemistry, I did only NCERT. Trust me, I did only NCERT and solved all the questions of NCERT and solved all the previous years. For physics, I read the NCERT, solved NCERT questions, read HC Verma, solved HC Verma questions. That's it. That's what my physics was, and eventually in JEE Advanced I got more marks in physics than in chemistry. HC Verma is a good book, that's why I recommend it. Yeah, and for mathematics again, I am not very sure. I'll be very honest with you. Neha ma'am is someone who can recommend you better books, better ideas on how to cover the backlog. What I did was I took my friend's notes. I got all of them photocopied. He used to make notes very beautifully. So I got all his notes photocopied. I started reading from the notes, and then I started solving the coaching material that had been given to us. So coaching material solve kiya tha maine mathematics ka. So this was my strategy, and I used to do this once a week or twice a week whenever I had the time to do so. Of course, it will be difficult. Of course, you will have to sacrifice a little bit on your sleep. Yeah, I tried sleeping to only for 5 to 6 hours whenever I was covering these backlogs. Yeah, so this is one time when you can cover your backlogs. Holidays, when you're sitting at home, Dussehra holidays, Diwali holidays, etc., etc. Then once the syllabus of 11th is over, there is some time before the 12th class syllabus begins. Spend that time to cover your backlogs. That's what I did. ठीक है, चलो. So Rakhi, the entire syllabus of 11th class chemistry should be done by the end of December ideally, but practically it might be plus minus a few days, few weeks. Chalo. Cool. So people, that's it from my side for today's class. Thank you so much for joining. If you enjoyed, please hit that like button, stay subscribed to the channel, and I will see you very soon. Until then, take care.